What's going on? Today we're going over OverTheWire CTF challenges. OverTheWire is actually war games site where you get to play different games to demonstrate your hacking skills. So basically, in today's video we will start with the Bandit series, and hopefully over time or over the next upcoming videos we will go over the next challenges. So for Bandit, we have up to 34 levels. In today's video, we were going to solve up to 10 levels, actually level 0 until level 10. That makes up 10 levels. Throughout these levels, we will demonstrate different Linux command line skills. So this video is a kind of Linux challenge, Linux command line challenge. We start with the very basic, and then as we go up higher in the levels, the difficulty goes up. So let's get started. If you want to go over the challenges yourself, just go to overthewire.org and then click on Wire Games. So in here you can go to Bandit, and from Bandit you get the instructions on how to connect. So if you click on level 0, in level 0 it is stating that in order to connect to the lab you have to connect over SSH to this domain on port 320, and the username is bandit0, the password is bandit0. Alright, so let's do that. So on my desktop here, let's connect. So SSH, I have it ready. I'm just gonna change 8 to 0. So now the password is bandit0. Alright, so level 0 to level 1. The password for the next level is stored in a file called readme, located in the home directory. Use this password to log into Bandit1 using SSH. Whenever you find a password for a level, use SSH on port 320 to log into that level and continue the game. So you have to find out the password for the user Bandit1. The password is located in the file readme. We have to find out that file. So we will use different, as I told you guys, we will use different commands in Linux terminal. So make sure you are familiar with these commands. If you are not, you can just research or learn of what we will lay down in this video. So here are the skills or the commands you need to know about to solve this level: ls, cd, cat, file, du, and find. Alright, so let's see first where we are. We are in /home/bandit0. We list the content of this directory. We have the readme file. If we cat the file, we see the password. Very basic, just train you on the use of ls and cat. So let's take the password, exit, and now change to user bandit1. Use the new password, and now we're connected to Bandit1. So now we are on level 1. Okay, on to level 1. So here is level 1 to level 2. So upon passing this level, we will go to level 2. Alright, so the password for the next level is stored in a file called hyphen or dash, located in the home directory. Okay, so if we type pwd, see where we are. We are in /home/bandit1 ls, and indeed we have a file whose name actually is dash. So if we type ls-la, see what kind of file is this. So as you can see, we have read write over the file with the user bandit. We have only read on the file because we are part of the bandit1 group. So now in order to read the file, we have two options. A file that starts with dash or hyphen can be read using two options. The first one, we use the stdin in Linux, which is cat and then stdin, as you can see, and then the name of the file. If we cat, we see the password. Okay, how about we try a different way? So cat, and then we specify the full path of the file. That's how we read the, if you don't know the stdin way, you can read the content of the file, or you can actually include the file in any Linux command line using the full path of the file. So if we go back now, type pwd, we are under /home/bandit. If you want to read the file, we can type cat and then the full path, and then the name of the file, which is dash. And now we are able to read the password. So let's take the password and move on to level 2. So now panda 2, type in the password, and now we are on level 3. Right, let's go now to level 3. The password for the next level is stored in a file called spaces in the file name, located in the home directory. So now the password, if you type pwd, we are in /home/panda2 ls-la, and now actually we have spaces in the file name as a name for the file. So as you can see, the file contains spaces in its name. In order to read the file, we need to enclose the name of the file with double quotes in order to be able to read that. So we type 2 double quotes, and we copy the file name, and we see the password. There is an alternative way if you want, which is cat, type the first letter of the file name, and then followed by tab autocompletion. If tab autocomplete is turned on, it will autocomplete the file name, and of course escaping the space with the backslash. So that's an alternative way if you want to read the file name. If it has spaces, you have the double quotes and you have the backslash to escape the space. Enter, and we read the content of the file. If tab autocomplete was not enabled in your case and you cannot use tab autocompletion, all you have to do is just to use the file name, the first word, and then we type backslash and then space in, and followed by backslash space this backslash space and then file name, and that's it. So now we take the password and we move on to the next level. Level 3 now. So now we are at level 3. We want to move on to level 4. Okay then. So the password for the next level is stored in a hidden file in the in here directory. So there is a hidden file, we want to find it. pwd ls-la, and indeed there is a hidden directory here called in here, c in here ls-la, and actually we see a hidden file. Note that if you only typed ls, you would not be able to see the file because the file is hidden, and a hidden file in Linux starts with dot. To display its contents, we type its name. It's that simple. Now we got the password. We move on to the next level. So now we are at level 4. Okay. Level 4. The password for the next level is stored in the only human readable file in the in here directory. Tip: if your terminal is messed up, try the reset command. Okay, so let's explore what do they mean by human readable file. pwd/home/bandit4 ls-la in here. Now we type in here, we cd to in here, and we have over 9 files, 10 files actually. And you can just go about and try to cut the content of every file, but that's not the intended way of solving the challenge. There is another way of solving the challenge. We have to use bash loops. So bash loops can be for or can be while loops. Okay, they are used to iterate through a number of files or through a number of iterants. In our case, we have several number of files. We want to run a single command against these files without the need to cycle through every file individually. So what do? We use a bash loop. A bash loop is useful for that purpose, to cycle through different variables, different files, using a single command. So we start with the for, and we use a variable called file or f, alright, and then we use in to indicate that we want to start a sequence from 0 till 9, followed by a semicolon, and then do After the do, we specify the command that we want to run. So which is file. I want to see the nature of every file. Human readable file tends to be either text or document. If it was binary, it wouldn't be human readable. So I want to find out the nature of the file using the file command. And then since the file name contains dash, right, I have to specify the full path of the file. Okay, we can specify the full path either using the full path here, okay, or we can just use the dot because we are at the same directory. So then we type dash file, and here we type 0 followed by the f variable. So why do we do that? As you can see, the pattern of the file name starts with 0 and stays 0 throughout all of the files, but the only changing number is the second digit. 0, 1, 2, 3, 4, 5, 6, 7, 8. So the only changing digit is the second digit. That's why here, because I'm using the f variable as the counter, I put here $f to indicate that I want to replace the variable f with its value from the loop. So the yielded file will be dash file 0 and 0 from here, dash file 0, and in the second round 1 from here, dash file 0, in the third round it will be here 2, and so on and so forth. And I type done. So that's the output. The output is, as you can see here, if the output of the file command if it was run individually. So as you can see here, all of the files are data except this one. It is ASCII text. So the file that I want is the file 07. So cat file 07, and here I got the password. So now I move on to the next level. Now we are at level 5. Okay, on to levels 5. Now we level 5, on to level 6. So now level 6. The password for the next level is stored in a file somewhere under the in here directory and has all of the following properties: human readable, 1033 bytes in size, not executable. So now we get to use the find command. Okay. So let me go to my notes and see what do we have on this command. So I'm gonna go to sysadmin Linux. So the find command, as you can see, I have different notes on the find command. Now we can use the dash size to indicate the size, and we can use dash executable to indicate that the file is executable, and we can specify the user, by the way. But here in this level, there is no need to specify the user. The only need is to specify the size and the executable. So let's try that. So pwd/home/random0 ls-la. Let's cd to the in here directory and start the find command. See how many files do we have in here? We have over 19 files. So I want to find out which one has the indicated size and is executable and is human readable. Let's use 2 attributes. All right, there is no need to use the 3 attributes in the command, in the find command. So let's start with find dot to search in the current directory, and then we start dash type to specify the type of the file, type of the entity, which is f, indicating that we are looking for files, and then we type dash size. We want to indicate the size now. The size here is measured in bytes, so we type the number and type C to indicate that we are looking for bytes. If it was megabytes, you type here M. All right, so dash C for bytes, and finally we type dash executable to indicate that we're looking for executable files, and we output, we send that to the dev null to indicate any errors. We don't want any errors into the command. So nothing. All right, let's go over the command one more time. So we got the size and we got the file type, but we can't find anything matching. Okay, let's cancel the executable. See if you can find any file that matches this size, and indeed we got one file that matches the current size, 1033 bytes. which is .file2. If we cut the content of the file, we should be able to see the password. And indeed, that's the password. So on now to the next level. So now we are at level 6. All right. Go on to level 6. So now we're at level 6 and we want to move on to level 7. All right. So the password for the next level is stored somewhere on the server. Somewhere on the server. All right. And has all of the following properties. The user is bandit 7 and the group is bandit 6, the size in bytes. And now we get to we need to specify the group and the user and the size in the find command. We don't know yet the path of the file, so what we want to search in all of the file system. So find slash to find slash to search throughout the file system, and then dash type f dash user. The user is bandit 7 dash group bandit 6 dash size to 3 bytes, and we send that to that null. Let me make sure that I type everything correctly. I'm gonna get back to my notes and see. So that's user, right? F for file size, but here our size is in bytes. This is the case for megabytes, by the way. So now let's start the search. And indeed we got one match. Let's see what is in this file. Cat. And indeed we got the file for level 7. So now we step the game to level 7. Bandit 7. Password. And now we are at level 7. Okay. Level 7 to 8. The password for the next level is stored in the file data.txt next to the word $1,000,000th. Okay, let's see first where is that file. ls, and indeed we got that file here. It's easy, right? But not that easy actually. If we cut the file, you see the file is overwhelming actually. There is no way to find and try every single password of these. So you have to find another clue. The password is next to the word $1,000,000th. If you look at the file, you see on every line you have a word and you got here the corresponding password. So our password actually is next to a word that contains the characters $1,000,000th. So we can use grep for that. We can cut the file and we can pipe the output to grep command. So what do you want to grep in here? We want to grep the pattern that we are given, which is $1,000,000th. And indeed, as you can see, we grab the password, which is next to the pattern we're given. So now on to level 8. Okay, now level 8. Things will get tough, I guess. The password for the next level is stored in the file data.txt and is the only line of text that occurs only once. You see the hints given in here, guys. It is the only the only line of text that occurs only once. It means there are duplicates in the data.txt. So this is a hint to eliminate the duplicates from the file. pwd ls, and here we have the data.txt. Let's display the first lines of this file. It's all passwords, as you can see, and according to the hint we got duplicates. So what do you want to do here? Let's sort them alphabetically, right, and remove the duplicates. So now we type sort data.txt. Okay, now we have sorted them alphabetically, as you can see here, the passwords. Now I want to eliminate the duplicates, so we type unique, or we type cat unique dash u eliminates the duplicates. Let's take a look here, and now we have eliminated the duplicates. now let's do this. Let's unify or combine them together. Unique dash u, and you see we got only one. So this is the password. Now on to level 9. Alright, level 9. No, we are at level 9. Yeah, level 9. We want to move on to level 10, which is the last level for this video. Let's see here. The password for the next level is stored in the file data to text in one of the few human readable strings preceded by several equal characters. Let's see that again. The password is stored in the data to text. Let's take a look at the file first. Cat data to text. So as you can see, we have non-human readable text in here. So as you can see here, stored in the data file in one of the few human readable strings. So we got some human readable strings. We want to extract them. That's the first hint. The next one, preceded by several equal characters. Our passwords, or the human readable strings indicated in the description in here, are preceded by the equal characters. The equal character. So now we have to do some filtering on this file. Of course, our friend in the filtering is the grep command. It does all the filtering we want. So let's clear and now use cat data to text. And since we're looking for only human readable strings, we're going to use the strings command. If you want to understand what I mean, just run the strings command on data to text. As you can see, when you run the strings command, you get to see human readable strings, right? That's the intended use of actually the string command. Let's get back now. Cat text, and then pipe that to strings, extract the human readable strings, and then we use a grep to look for patterns where the equal sign is preceded at the very first of the string. So we type equal sign. Before that, we type one arrow here. Let me look at the arrow in my keyboard. Where is that arrow? Okay, let's see here. Now we got 3. I'm not sure that's the correct method. Let me see that again one more time. Let's see this. Nope. No such file or directory. So we have password. Is it possible that the password actually is password? The only human readable string here preceded by the equal sign is this one. Let me cat the file. And send that output to strings. See what is the output in here. So we got this one, equal sign, and there is this one. There is this one indeed. And there is this one. But we only got, as you can see here, 3 of them. The one that we didn't get when we run the command is this one. And I think this is the password. And the only reason we didn't get that is the presence of the ampersand in here. So if we type the ampersand here, grep the ampersand, and then we need the other character. Let's try that. This time it didn't work because we have several instances where the ampersand actually exists. So equal. Alright, so when we type grep equal, we got several matches, as you can see, but not all of them starts with the equal sign. We return the strings where the equal sign actually does exist, which is fine. As you can see, this is the password, and now you can log into level 10. See if that works. It works. Now we are on level 10, and we will step to level 11 and all of the other levels in the upcoming videos. I hope you find that informative, and see you in the next video, guys.